Hi, this is your exam 2 review, part 3 for prep for calculus. We're going to be going over questions 18 through 25, and we'll start on number 18. Without using a calculator, rank the following in order from smallest to largest. So, what I see here is I see a bunch of cosines and degrees. I know that cosine is the x value of the circle. So that means on my circle, the more to the right I am, the higher my x is. So this is going to be, we'll make that plus, we'll make that minus. So if I'm on the right side, my cosines are going to be bigger, and if I'm on the left side, then my cosines are going to be smaller. So I'm going to draw all of these. So we have cosine of 12, which will be about there. 12. And then 45 or 85 will be up here. 165, 180, 165, and 520. Right, so I know that this line here is 0, this line is 90, this line is 180, and this line is 270. So I kind of drew those lines based on those degrees that I knew. And now we're going to find the points. So our smallest point is cosine of 180 as the biggest negative number. So it's the smallest. The next one is going to be this 625. So cosine degrees. Right, next one is going to be this one. The next one's going to be this one. Right, and these ones are very close. But this one is 10 degrees away, and this one is 12 degrees away. Right, so that means 12 is further away from 0 than 10, so the next point is going to be 12. And then cosine of 350. Right, and so we got that one. Okay, so there's our list. 180, 165, 265, 85, 10, and then 35 degrees. So, find the angle between 0 and 360 degrees that have the same, and then it says cosine of 230. So, I'm going to draw, so I know this is 180, it's 270, it's 90, and that's 0. So I know this point is going to be around over here. Okay, since it's cosine, I know it's going to be the same x value. So it's going to share this line here. Right, and the other place that it touches the line is right here. So we have this. And so in order to find this angle, I know that this angle here is the same as this angle here. So I can find out what this angle is, and this angle is 320 minus 80 degrees, which is 50 degrees. Right, so 180 plus 50 degrees gets us 320. So now if I go this way 50 degrees, I'll get the point we're looking for, or the angle we're looking for. And that's going to be 180 minus 50, which is 130 degrees. Okay? And then for this one, we're going to have the same here. And sine of 105. So we're going to be about in the middle again. And so we know sine is the y value. So we're going to draw our dotted line wherever our y value is. And we see that it connects here. Right, so our other angle is right here. And what we know about these angles is that they share this angle, and this angle are the same. So I can do the same thing. I know that this is 305. So I know that this angle, so I know that 305 plus our theta is going to equal 360. So if I subtract the two, I can get theta, and theta will be 55 degrees. And I know that if we add this theta to here, we'll get this point. So 180 plus 55 degrees equals 235 degrees. So the similar angle of that one is 235 degrees. All right, question 20. Find 4 positive angles in the different quadrants with the same reference angle as negative 105. So if we're going in the negative direction on the circle, we'll start at 0. And if we go this way around, we're going to get to negative 90 degrees. This will be negative 180 degrees. So that means our angle is about right here. So if we know that that is right there, we can calculate our reference angle, which is going to be this angle, theta. All right, so we know that in order to get negative 1, so we know to get to negative 180, we have to add this angle and this angle. So this angle is our negative 105 plus theta, and we can calculate what theta is. So theta is going to be equal to negative 75 degrees. Right, so that means that this angle here is 75 degrees. So if we know that this angle is 75 degrees, then all of our other lines are going to look like this, with these angles also being 75 degrees. So if we start from our coordinates, in quadrant 1, we start from 0, and we go around to 75. So 0 plus 75 is 75. So this is just 75 degrees. Let me write that smaller. Okay. So for our next quadrant, we know that this angle here plus this angle here gets us 180 degrees. So that means 180 degrees will be equal to 75 plus theta. So if we subtract that 185s and go backwards, we'll find out what our theta is. So 180 minus 75 is equal to 105. So the angle in this quadrant is 105 degrees. For our next angle, we're going to be adding 180 to 75 because 75 is a continuation on top of 180. So that's equal to 255 degrees. And then to get this big angle here, We start at 360 degrees and go backwards 75. So 365 minus 75 is going to be equal to 185 degrees. So that's all of the angles in each quadrant. All right, question 21. Name 3 angles that are coterminal to negative 40 degrees. Then name 3 angles that have the same reference angle as 400 but are not coterminal to negative 40. So let's draw our angle first. So we're going backwards 40 degrees, which puts us around here-ish. Right, and we have to name 3 angles that are coterminal. So that means we're going to find 3 angles that are going to go around the same amount on the circle and we're going to end up right here. So the first thing we can do is find out how we can go all the way around. Right, so that's just going to be adding 360 plus that negative 40 degrees, and that's going to put us at 320 degrees. Okay, so on a number circle from 0 to 2 pi, this angle of negative 40 is going to be at 320. And in order to find more angles, we can just simply add 360. So that would be equal to 680 degrees. Or we can subtract 360. So if I did minus 360, I'm going to get 400 degrees, or negative 400 degrees. So that would be 3 coterminal angles, negative 400 degrees, 320 degrees, and 368. So these are all coterminal. To find some angles that have the same reference angle but are not coterminal, we have this theta here that is 40 degrees. So we can find angles that also share that, which are going to be these. So that's going to be 40 degrees, that's going to be 40 degrees, and this is going to be 40 degrees, right? So this one's simply adding 40 to 0, which means we have 40 degrees. So, all right, RA. This one, we're at 180 and we're going backwards. So that's 180 minus 40. So 180 minus 40 is equal to 140 degrees. So 140 degrees. And then the next one, we're simply just adding 180 to 140 because that 40 degrees is going to be a continuation of 180. So 120 degrees. So there's 3 reference angles and 3 coterminal angles. There are other answers for this one, but those 3 work for each problem. So question 22, find the coordinates of the point on the circle of a radius of 3.8 centimeters at an angle of 200 degrees, centered at the origin round to 2 decimals. So I need to find a coordinate, I need to find an x and a y point. And so I know that we can find the x coordinate because the x coordinate is equal to cosine. But this circle has a radius of doesn't have a radius of 1, so we're going to multiply that by r. And the same for the y. You know, the y value is going to be equal to sine, but the radius is not 1, so we're going to multiply that by r. So we can just plug what we know in. So x is equal to the radius 5.8 times cosine of 200 degrees, and y is going to be equal to the same thing but sine of 200 degrees. And so we're going to plug these into our calculator and make sure that we are in degrees when we do so. So 1.58 times the cosine of 200. And we get negative 5.45. And that makes sense because we should be at a negative x here. And we should be at a negative y because we're going down. So for y, same thing, 5.8 times sine of 200 degrees. And that's going to be negative 1.98. So our point, combining our two answers, is going to be this. So for question number 23, it says assume the equations for a, b, c, and d can all be written in the form y equals ab to the t. So I know in this equation that we have a and we have b. A is going to be our starting value. When we have a, b to the 0, this a, b to the 0 is going to go to 1. So a times 1, and we're just going to be left with a. So whenever t is equal to 0, we're going to have a, and a is going to be whatever our y-intercept is. So that means that we can find them. So here, right, this line A here and this line C here both have the same A value. This B value is up here, and this D value is going to be here, right? And then the B value is our rate, or our like slope of this equation. It's the rate of change for this. So I know that if my graph looks like this, I am growing. And if my graph looks like this, I am decreasing. If the line is steeper, I know I have a higher value. And if it's flatter, I know I have a lower value. So using that information, I'm going to answer A through D for this problem. So which function has the largest A value? We answered that in our explanation. That's going to be B, because B has the highest y-intercept. Which two functions have the same A value? We answered that too. Here, A, the gold line A and C both share a y-intercept, so they have the same A value. Which function has the smallest B value? So for B values, we know that B can either be in between 0 and 1, and then we know that B can be greater than 1. And when this happens, our slope is decreasing, and when this happens, our slope is increasing, right? And what I was saying before with the rate, whenever this B value is higher, it's going to go up faster. So it's going to look more like this and kind of be at a higher number than if B was equal to something lower. And if the B was closer on this graph to 0, it's going to have a steeper increase and a steeper change. So that means if we have this decaying function that's decaying very fastly and very rapidly, like that I see in B here, our line is almost vertically straight down, then I know that my B value is very close to 0, which is going to be the smallest value of B that I can find. So this is going to be B again. Then it says which one's going to have the largest. If I look at the other values, this one is going to be less than 0, or greater than 0, but less than 1. So probably not that one. This one, D, is growing, so it could be that one. But I see C here. C is growing even faster than D. So I know that it has a larger B value. So the answer to D is going to be C. Number 24. Shown are the three exponential functions. Order the constraints A, B, C, and D from smallest to largest using the information obtained from the graph. So, here we have C, D, A, and B. So, I know that A is our starting value, our y-intercept. So I'm going to mark those. So here is that one, and here is that one. And we can compare it to g of x, the black line. So I know when e to the 0 is equal to 1. So I know that this, since c is equal to this line here, I know that c is equal to 1 also. So that means I know that d is less than 1. Okay? Then I have to figure out what b and d are. When d is negative, I know I'm decreasing. And when it's positive, I know that we're growing. So here we know b is decaying, or we know d is decaying because it is decreasing. So that means we know that d is negative. Right, so if we just chart what we know now, d is going to be a negative. This is an A. A is going to be less than 1. And C is going to be equal to 1. Okay? For this e to the x graph here, there's a 1 in front of that x, right, to show that this value is equal to 1. So we know that this graph here has a slope of 1. This pink graph is increasing at a rate faster than e to the x. So that means that b, since it's growing and positive, is greater than 1. So I can rank these. So since d is negative, it's going to be first. A is less than 1, so it's going to be next. C is equal to 1, so it's going to be next. And then B is greater than 1. So we know that that is the order from smallest to largest. Question 25. Each of the functions shown are in the form of y equals k plus ax to the ab to the x, where k represents the vertical shift. Identify the graphs number 1 through 4 that appear to the given satisfied conditions. So, a is less than 0. So, I see one graph that fits this condition. I know when a is less than 0, that means that it is negative. And that means that we have a negative b to the x graph. And that means we're going to flip from this, our normal graph, over the x-axis to down here. So our graph is now going to point downwards. And that fits condition 2. K is equal to 2. So that means we moved up 2. Our standard graph starts at 1, because it starts at whatever A is. So we have B to the, whenever we have B to the 0, that equals 1. So then we have A times 1 is just equal to A. So normally, if A was 1, it would be 1 times 1 equals 1. And when we moved up 2, we would then be at 3. And this graph here has only moved up to 3. Everything else looks the same. So I'm going to say that 1 is k is equal to 2. But also, this graph here is at 3. So we can say that graph 3 is also at 3, and for that same reason, we can put 3 also. Sorry, I didn't put enough room on this line. 1 and 3. So the next one, B is in between 0 and 1. So when B is in between 0 and 1, I know I have decaying graphs, which I do have 2 decaying graphs. I have this one, number 3, and this one, number 4. So 3 and 4. So f goes to 2. So as y goes to 2, as x goes to negative infinity. Or as x goes to infinity. So I know that we have an asymptote here at 0. Or not 0, at 2. And as we're moving to the right, to infinity, we're going to still be at 2. And when I look at this asymptote I just drew, I see this graph number 3 getting very close to it. So I know that this one is going to be graph number 3. And then as y goes to 1, as x goes to negative infinity. So I'm going to erase all of this and apply the same logic. I'm going to draw an asymptote here at -1. Right, and I know as we go this way, we're going to get closer and closer to 1. And the only graph that gets closer to 1 as we get into negative infinity is this 2. So I know that this one is going to be equal to 2. So that's part 3 of your exam 2 review. If you have any questions, let us know, and we will see you in part 4.